All right, good morning, class. We're going to look at chapter 2, part 2. So, just the second set of the chapter. Uh, Again, we're going to have this broken down into four sections. Um, so, we can have, just some bite sized sections that we need to do. So, this will be part 2 of it. So, the next one you'll be doing is the top cover lesson, and I'll have the video up for it. But in that, you'll look at some different boss and cut and connect conditions, what shelling apart is and how to do it, alternate ways to add fillets, and then measuring geometry. Um, so basically you can just measure the geometry just to look, or um, you can use your smart dimension tool to do something like that. Um, but on the boss are cut in conditions. So there's your extruded boss base. So if you just want to extrude a feature out, either from a datum or from a face of a part, a revolved boss or a base. And what that is like if you drew a profile of a particular feature. So think of something like a chess piece, like a bishop, something that can go all the way around. Or if you drew one half of it and revolved it around, a center line, you can have a piece that shows 360 degrees. A car wheel, anything like that where it's going to come all the way around 360 degrees, and you'll have that same profile basically all the way around. An extruded cut, so it would be just the same thing as an extruded boss or base, except you're going to cut instead of adding material, you're going to take away material. A revolve cut, again, instead of adding material, you're going to take away material, but you're going to have it revolved. An extruded surface, so if you're not having like a full feature, if you're just going to have the surface extrude, like we're looking for shelling apart, and the same thing with a revolved surface. So if you're going to have something hollowed out. And then sheet metal base flange, which we won't get into sheet metal parts just yet, but he'll go over some of that in the video. So shelling apart, so the shell tool hollows that apart, leaves the open faces you select, and creates thin-walled features on the remaining faces. Right, so it basically just creates a shell of whatever part you've modeled, and it sets the thickness at whatever you set for that shell. If you do not select any face on the model, you can shell a solid part, creating a closed hollow model. You can also shell multiple, or you can also shell model using multiple thicknesses. If the shell tool has problems shelling a model, the error diagnostics section appears in the property manager to help you diagnose the problem. With fillets, so these are basically just rounded corners, right? Either inside or outside, so fillets and rounds. A fillet or a round creates a rounded internal or external face on the part. You can fillet all edges of a face, selected sets of faces, selected edges, or edge loops. And an edge loops would be just if you had multiple edges going around the part, like if the top of it was like a bolt, right? You have 6 edges, but they all create a loop, so you can do a fillet on all those at one time. The fillet property manager, so you can use the fillet property manager to control options for fillet features. The property manager displays the appropriate options based on the type of fillet you create. The property manager remembers its last used state. So, if you have a certain radius in there for the fillet, it'll remember that as you go. Constant size fillets. These create fillets that have a constant size for the entire length of the fillet. So again, if we go back to the bolt, you had a rounded edge and not a chamfered edge, and you had that radius on there of a quarter of a millimeter or 0.25 millimeters. It would keep that constant size all the way around. Variable size fillet creates a fillet with variable radii values. You'll use control points to help define the fillet. So if you want to go from a large fillet to a small, or small to a large, you can use a variable size fillet. Using variable radius control points, so you can manipulate and assign radius values to control the points of the vertices of asymmetric or symmetric variable size fillets. Face fillets, these will blend non-adjacent or non-continuous faces. And then full round fillets. So these create fillets that are tangent to 3 adjacent face sets with one or more faces tangent. So think if you had a part that had it was flat on top and you had two edges on each side. You could use a full round fillet too. You're basically just making this one big round all the way across. So the top face would essentially almost go away, except for one exact point in time. So that's what a full round fillet would be. And then for the offset shaft lesson, so again we'll post a video for these so you guys can see the tutorial. But you'll talk about the boss extrusion, so like we just talked about. Tolerances. So we looked at setting the amount of decimal places we wanted to have. So 1, 2, or 3. So your tolerances will be the same. Do you want to have this to one decimal point of precision, 2 or 3? A revolve cut. We talked about this. Auxiliary planes. So in the beginning, you have your front, top, and right planes that you can use to draw off of. Depending on different parts, you may want to set up auxiliary planes. So what this will do is, let's say you wanted a plane that's at 45 degrees to your front plane or your top plane. So you can develop an auxiliary plane that's going to be at 45 degrees to that plane, be on perpendicular or parallel on the other plane, but 45-degree angle to that plane. And this will allow you to draw features, from that plane. So if you want to offset a feature or if you needed to project a feature down, you can set up this auxiliary plane and draw from there to, draw features that aren't going to be, maybe normal to your front, top, or right side planes. Convert entities. So this is a tool that you can use with that. So if you did a sketch on that plane, you want to convert it and put it down onto another surface or a plane or something like that, you can use convert entities, to project it down so that you can draw a feature on like a rounded face or something that may have an angle or something like that, something where it's not may not have a flat surface to draw on. And then the polygon sketch entity, so you can draw a polygon that's going to have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides, just to do a quick symmetrical polygon.